Hello, this is Kevin Trainer. Welcome to my lecture on the chapter 14 of the Python book by Severance called Python for Everybody. In this particular chapter is about Python objects, and this is kind of a turning point for Python beginners. And the turning point is really kind of works this way. Okay, we've been using Python objects all along in our course, right? And sometimes we've talked about them as objects, and we've kind of emphasized their object-oriented nature, and other times we haven't, right? And now what we're going to do is we're going to call attention to the object-oriented aspects of the Python we've already been using. And then we're going to uncover some additional capabilities that are here for your use. And this reminds me of a famous quote from the French author Moliere. And so I guess this is a play. So Monsieur Jourdain says, "Oh, really? When I say, Nicole, bring me my slippers and fetch my nightcap, is that prose?" And the philosophy master says, "Most clearly." And Monsieur Jourdain says, "Well, what do you know about that? These 40 years now, I've been speaking in prose without knowing it." Well, and there's some humor there, but we all speak in prose. And at this point, we all write Python, if you're in my course. And yet, one of the aspects of writing Python is you're working with Python objects, and you're really not concentrating on it for the most part. And what we're going to do now is we're going to concentrate on it because we think that now that you know how to speak in prose, being able to concentrate on it as prose has some benefits. Okay? So, here we go. If we can only get the slides to move. So there's a warning here from Severance. And he's saying that this is a very mechanically oriented chapter. And you have to understand the mechanics, but then you have to understand how it works. Well, that's going to work out very well for people in my class because we're going to go through this chapter material. And then associated with the exercises that we're going to do, we're going to have a tutorial for each of the exercises. And in the tutorial, this is a case where you're going to see it working, how it works, what the applications are. So that's one of the reasons why I decided to use the Severance chapter 14 at this point in our course. Now, I've said that we've been working with objects all along, okay? What are some of the objects that we've been working with? Well, in Python, all of the values that we work with are objects. Okay, so integers are objects, floats are objects, strings are objects, okay? But probably the one object type that we've been dealing with that's probably more akin to the kind of objects we might create ourselves if we were to create them with custom classes that we created are the lists, right? Because as we're going to find out, objects have both data and behavior. And we probably think of our lists as pretty obviously having both data and behavior. The data are the values that we put into the list. And if we do it programmatically, we do it with the append method of the list. Okay, but we can do some, we can call some other methods as well. We can call extend, insert, remove, pop. So working with lists, we kind of have this idea that a lot of times we might want to manipulate the sequence that's in the list. And these are ways that we do it by calling the methods that we see here. But we also know that the individual items on the list have a value. So we have a sense of both the data aspects of the list and the method or the functional aspects of the list. Okay, so I think this is a classic case where we're using objects and we're really thinking of them in the full object-oriented sense. Okay. Another another feature of what's available to us in Python that Severance offers for us to think about is that if we want to work with databases, okay, what we might want to do is we might want to work with a database like SQLite, which is a lightweight kind of a learner's version of an SQL-oriented relational database. Or eventually we might want to work with MySQL or Postgres or Oracle, okay? And what we usually do when we work with these kind of, I wouldn't really call them add-ons, they're kind of bolt-ons to Python, is we import one or more modules, in this case SQLite 3, or I don't know how people say this. Perhaps I just say SQLite 3. I call it SQLite 3. And then we can use all of the classes, all of the object types that are part of that module. Okay, so pretty typically, anytime we want to work with a whole new capability for Python, okay, what we're really doing is we are importing via importing the modules a bunch of class definitions and function definitions and things like that that are associated with that capability, and then we use those kinds of objects, right? So this is what makes Python such an extensible language, and why it's so appealing and useful. Okay, so pretty much any kind of really interesting thing that you would want to do with Python, having to do with, let's say, computer graphics or data analysis or relational databases or creating a web application serving a web serving application. All of these things are going to require that you import one or more of these packages that are contained in modules, and you begin to use the classes that are inside of them. Okay, so maybe we've only done a modest amount of that so far, but as you grow in your usage of Python, that's where you're headed. Okay, and the reason you know that you're going to be able to do that well is you've at least worked with a list. which are, kind of sort of implemented with the same architecture. All right, ahead we go. All right, let's start with programs. Okay, so here we're exploring the program capabilities that we've been using so far. These are the first kinds of things that we learned how to do. We learned the pattern, kind of the big pattern, input, process, output. So here's a case where we're trying to create some code that helps us to translate between the way that they identify the floors of a structure in Europe compared to the way that they describe them in the US. And many of us are aware of that, and some of us are not. So in Europe, typically the ground floor is not the first floor. Okay. In fact, if we put in Europe floor 0, our code gives us back US floor 1. Okay? And you might not know that. I happen to know that. This is certainly true in France. Okay? So, how do we do this? Well, we prompt the user for the Europe floor. Okay. And we get a string called imp. Probably not the best variable name. Convert the integer. We convert the digits of the string that we got in imp to an int by calling the function int, and then we add 1. So now we have USF, which could mean the University of South Florida, but I think he means it to mean US floor. He's very cognizant that he has a left part of the slide and a right part of the slide, and he doesn't want them to collide. So hence the motivation for the bad variable names. And then he prints US floor and then the value of USF. And that's how we get US floor 1. Okay. So this is the kind of work that we've been doing so far. So what are the objects that we're dealing with in this code that we saw? Well, strings are implemented as objects. Okay, so we have a string object. We read another string object, imp. We convert between a string object and an integer object when we call int with imp as an argument. We use the literal value 1, which is an integer object. When we print, we're using a string object and an integer object. So we've been using objects all along. Okay. Now we're just going to become more facile, and we're going to learn how to create our own classes of objects, which is going to be fun. So in an object-oriented programming language like Python, a program is made up of many cooperating objects. Okay, and we just really talked about some of the obvious objects about that simple program that we had. Instead of being the whole program, each object is a little island within the program, cooperatively working with other objects. Okay, and we could see how the string objects and the int objects were kind of orchestrated by the code that we wrote. Okay, so a program, an object-oriented program, certainly a Python is an object-oriented program, is made up of one or more objects working together. And these objects make use of each other's capabilities. Now this is a pretty interesting thing because it turns out that strings and integers kind of have a relationship to each other, where you can convert one into the other by calling the function int on a string. So that's a kind of cooperation. Okay, and I like to think of this procedural code that we see here as kind of an orchestration of the objects as they cooperate with each other. Okay. So, an object is a bit of self-contained code and data. Okay. A key aspect of the object approach is to break the problem into smaller, understandable parts. This is essentially the divide and conquer strategy. Objects have boundaries that allow us to ignore unneeded detail, and you'll see what I mean by this in a minute. We've been using objects all along. I began with that. String objects, integer objects, dictionary objects, list objects. They're all objects, right? So even though we might have been not thinking of this as object-oriented programming, that's what we've been doing. Okay, so let's focus on the object aspects of the things that we've been doing. So in the course of our coding, like the procedural coding that we saw in one of the opening slides, objects get created and used. So the overall pattern that we're trying to follow here is input, process, output. Okay, so we get, so we get input from the user and we give output back to the user, but in between there's this cooperating bunch of objects that are being kind of orchestrated by our procedural code. Okay, so we might have a string object, we might have a dictionary object, and we appear to have some other objects here that we haven't really said what type they are. Okay, perhaps we'll find out. Okay, and it's really interesting to know that objects are a combination of code and data. Okay, they have a data, they have values, and they have code, they have behavior. Okay, and one of the really ingenious parts of object-oriented programming is that these objects are little packages that combine appropriate data values with appropriate code or behavior values. And they're packaged up in a really powerful way. Okay. So one of the things that objects do is they create a boundary around the context of whatever programming is going on inside that object, where we can ignore the detail of the rest of the program and just really concentrate on what's going on inside and how to cooperate with things on the outside using the explicit interfaces of whatever object, whatever bit we're in. Okay? So we get to concentrate on, in this case, we're concentrating on the code and the data that are part of this object that's in the upper right. Objects hide detail. They allow the rest of the program to ignore the detail about us. So it really cuts both ways, okay? The rest of the code in the program, okay, it can have two kinds of relationships to the code of interest. So the code of interest is the code that we were looking at before. It's grayed out here in the upper right. Okay, and you can see that the object on the lower right doesn't have any connection to the object in the upper right. Okay, so it can really completely ignore the object in the upper right. It's not really related to it. Likewise, the object in the lower left uh, doesn't have a direct connection to the code in the upper right, to the object in the upper right. And so while we're dealing with programming and testing these objects that don't have any connection to the object in the upper right, we don't really even have to consider the object in the upper right. What about the object in the upper left? Well, it does have a relationship um, to the object in the upper right, but as I mentioned before, to the extent that these objects interact, they interact through their interfaces. Okay, and typically, a typical way that these might interact is that the code in this upper left object might call a method in the code that's on the upper right object. Okay, and then how do they interact with each other? Well, the calling code, passes parameter values to the called code, right? Um, and the called code sends back return values. That's it. So the interaction between these is highly circumscribed, right? So this ability, when we're working on code, to only consider the code that we're on, and to the extent that we need to consider other code, only the explicit interfaces, makes our coding easier to write and infinitely easier to test. Okay, here's some definitions. So far we've been talking about those objects without really talking about where they come from. Okay, and the built-in types come from Python. You can think of these types as being based on classes. Okay, in certain cases they are, in other cases they're not. They're just kind of a built-in amalgamation of features that behave like classes. But you can think of them as classes. So a class is a template for an object. And what we're going to be able to do when we complete the chapter here is we're going to have enough information to create our own custom classes, which means that we can actually craft our own objects, our own type of objects. We haven't been able to do that up until now. We've just been using the built-in ones. Okay? Now, what kind of properties do these objects have? Well, they have data and they have behavior. Oh, okay. So the behavior is typically called in our programming terms a method. Okay, just like a function. We've been using functions all along. So if you take a function and you say it's part of a class, then you more properly call it a method. So it has a name. We form the name just like a function name. You can pass it parameters, and it can send you back return values. That's it. What about this word message? Well, there's a way of talking about object-oriented programming where you talk about these objects cooperating with each other by sending each other messages. It's another metaphor. It's never one that's appealed to me, but it was one of the earliest metaphors used by computer scientists who developed object-oriented programming. So it's a pretty important term, but For me, it's just as easy to say message is another metaphorical way to refer to a method. Okay, so we call a method, when we do that, certain people might say that we're sending the object a message. Okay. The other thing that we can have is data. Okay. Um, we can think of the data associated with a class as a field for that class or a data attribute for that class. Now, I just want to point out that the word attribute is also used in a general sense to refer to methods and fields. Okay, so in a very broad sense, okay, both methods and fields are attributes of classes. Okay, more typically though, when people say attribute, they mean data attribute or field. Okay. And we also have objects or instances. So it's a particular instance of a class. So, we're used to object instances. We might have an integer type object that has the value 1. We might have another an integer object that has the value 2048. And those are both instances of integer. The same thing with strings. We might have an instance of string that has the value Kevin, and we might have an instance of string that has the value Mary. Okay? These are both object or instances of the string type. Okay? And again, these built-in types, you can think of them as classes. Can you actually go somewhere and find the code for that class? Well, in some cases you can, in some cases you can't. But in any case, they behave just like the custom classes that we create. So let's go over some of the terminology. So what's a class? So a class defines the abstract characteristics of a thing, an object, including the thing's characteristics, its attributes, fields, or properties, and the thing's behaviors, the things it can do, or methods, operations, or features. So data, behavior. Okay. So classes, it define the data that objects will have and the behavior that they will exhibit. One might say that a class is a blueprint or a factory that describes the nature of something. For example, the class dog would consist of traits shared by all dogs, such as breed and fur color. Those are characteristics. And the ability to bark and sit. Those are behaviors. So if we had a dog class, right, the data aspects of it might include breed and fur color, and the behavior aspects of it might include bark and sit. So data and behavior. And I just want to point out, I've given out a copy of these slides in the weekly schedule. You can pretty much click on any of these and go to whatever it points to. So this slide has a link for the main Wikipedia article about object-oriented programming. And I'm not saying that you have to go there, but as a resource, I think it's pretty darn good. Okay. Okay. So let's see. We were on the terminology. So we had a class. Okay. Now we're going to talk about instances of the class. Okay. One can have an instance of a class or a particular object. These are two ways of saying the same thing. Okay. So The instance is the actual object created at runtime. In programmer jargon, the Lassie object is an instance of the dog class. Now, to understand this, you have to understand that there was a TV show certainly in the 1960s, but it probably started in the 1950s, called Lassie, in which there was a boy called Timmy, and he had, I think they lived on a farm, and he had this collie dog named Lassie, and they had these very homespun adventures, and Lassie would always kind of save the day. The classic is where Timmy fell down a well, and Lassie came back to get Timmy's parents and to lead them to the well so that Timmy could be saved. Okay, so that's why the Lassie object would be an instance of the dog class. Okay, so the set of values of the attributes of a particular object is called its state. The object consists of state and the behavior that's defined in the object's class. So when you think of this, at any particular instant in time, the data part of an object has certain values. They're in a certain state. That's what we mean by state. Okay, so in object talk, which we're doing right here, right now, the words object and instances are often used interchangeably. Okay, so we might say we have a dog class, and we have created 4 instances of it: Lassie, Rover, Fido, Killer. Okay, or we might also say that there are 4 dog objects. Pretty much we're making the same claim. It's just that, like in any trade, which is what this programming biz is, we have a couple of ways that we say things, and we're pretty comfortable at kind of switching off between one set of terms and another set of terms. So you'll find that people switch off between the words object and instances, object and instance, pretty freely. Okay? Method. An object's abilities are expressed in the methods that are part of the class. So in language, methods are verbs. Lassie being a dog, he has the ability to bark. So bark would be implemented as one of dog's methods. She may have other methods as well. For example, sit or eat or walk or save Timmy. Okay, she was forever saving Timmy, especially in that classic episode where Timmy was in the well. Within the program, using a method usually affects only one particular object. All dogs can bark, but you need only one particular dog to do the barking. Okay, now method and message are often used interchangeably. Now, I'm not going to be using them interchangeably because the messaging metaphor of object-oriented programming, it's a metaphor that's never really appealed to me personally. Okay? It has a great tradition in computer science, and I think it was probably instrumental in computer scientists kind of understanding what object-oriented programming was and how it could work and how to describe it in a general way. So you might find in some writing or textbooks people using method and message interchangeably, but you won't have that risk with me. Now, here are some Python objects. We've done this before. Okay. Earlier in the class, we were using the Zell book, and we created some objects that had a certain type, and then we went and explored what that type was. And what's interesting is that they told us what class was associated with it. So here we say that the value x is going to take on the string of value ABC, and then we ask for the type of x here at the Python console, and it says it's a class string. Okay, and then what's the type of the literal 2.5? Well, class float. What's the type of the integer 2? Class int. So we say we want to create a list. Okay, it might have been yeah. Here's one way to create a list is to call the list function. So this is a way to create the empty list. We could have also just put empty square brackets to the right of the equal sign, right? And now it says the type of the variable y is class list. And then we create a dictionary the same way. Here's how we would create an empty dictionary. And it says the type of the variable z is class dict. That's for dictionary. Okay? And in fact, if we go over and we use the dir function, which is short for directory, each object has a directory that has a lot of its, it has really all of its attributes in the wider sense of the word attributes. So data attributes and methods. So let's say x is a string. So we say, what are the various attributes of a string? Well, we do that with directory x. And let's see, it's got capitalize, casefold, center, count, and code. These are all the methods you can call on it. Okay? And then y is a, what is y? Y is a list. So what can you do with a list? Append, clear, copy, count, extend. Well, you can do all those things. You can sort. And z is a dictionary. So what are the attributes of a dictionary in this wide sense of the word attributes, which includes both the data attributes, the fields, and the behavior attributes, the methods? Well, clear, pop, from keys, get, all those things, right? So again, are these built-in types implemented as classes? Yeah, they behave as classes. Can you find the code for that class? It would look like a class that you would write. In some cases, yes. In some cases, no. When you find the code, it looks slightly different from some class that you and I would write. But it certainly behaves like one that you and I would write, but with a lot of capabilities. Okay, let's go to a sample class. Okay. So our friend Mr. Severance, probably Dr. Severance, I guess, has created a class called Party Animal. And let's just look at in the middle column here to see the text that's part of that class file or module. So we begin with the class keyword. It's a reserved word. And then we have the name of the class. Classes are the only thing in Python where we use classic camel case capitalization, like the kind of name forming conventions you see in languages like, say, Java and JavaScript. Okay, so the class party animal is not party underscore animal in all lowercase, but party animal with initial caps on each of the words and then lowercase for the rest. Classic camel case capitalization. Okay, so we have the class, we have the name, we have a colon. Okay, x equals 0. Well, see, x is some kind of a variable, right? And we give it the value 0. What does it mean to be a variable that is inside the class but outside the methods? Well, it is called an instance variable. And sometimes you'll see them declared here and sometimes you won't. Okay? But this is one of the ways that you see them. This is maybe the most obvious way to say the class has a data bit. Okay, we say that classes have data and behavior. So what are the data bits? The data parts are instance variables. They're the data attributes. This one's called x. It gets an initial value of 0. Okay. Where are the behavior bits? They're in methods. And you might say, geez, a method looks a lot like a function. And I would say, yes, a method is a function that belongs to a class. Okay, and how do we know it belongs to the class? Well, you can see it's indented under the class. Okay, that's how we know things belong to each other in Python, through indentation. Okay. Also, methods get a really unique kind of formal parameter called self, and we'll get back to what that means. Okay, and let's see, self.x is the way that we refer to the instance variable x when we're inside of one of the methods. Okay, so if we're not inside of a method, we can just use the expression x, but if we are in a method, we're going to use self.x. So let's see, we're partying. Okay, so what's a party animal? I think interesting. Severance, I think he teaches at the iSchool at Michigan. And of course, Michigan, like all the Big Ten schools, I teach at 2 places, including another one of the Big Ten schools. The undergraduates have a tendency to party. In fact, they've had competitions from school to school, which is the biggest party place. So Severance, I think, is kind of joking that we would be interested in the party animal class. Okay, a party animal is, I think, a student who likes to party. Okay, so what's the behavior that we get? Well, it looks like every time we call party on a party animal instance, we increment x by 1. I don't know what x is supposed to represent. Perhaps the intensity of the partying of this individual party animal. And then we print so far as self.x. So the first time we come through, we would have had the initial value of 0. We would have incremented it by 1. So we would say so far 1. And then if we call party again, it would say so far 2. Okay, now down at the bottom here, we have some code that could be in the same file. Okay, but it doesn't have to be in the same file. You and I will probably typically put the definitions of our classes in one module, and our code that uses the classes, sometimes called client code, okay, into another module. Okay, that promotes reusability. Okay, sort of implicit in the value of classes. One of the values as classes is the fact that we can reuse them in a lot of different programs. Well, if we bind them up with all the individual application logic every time, that doesn't make them as reusable as they might be. Okay, so you can think of this. We could create a single file that has both the definition of the class and the code that uses it. But that would be a kind of a one-off use of a class, not typically the usage that we're looking for. So this is the client code. So we declare a variable an for party animal. Again, this isn't a good variable name, but he's trying to maintain 3 separate columns here. You have to cut him a break, right? So this is how we construct a new party animal. Okay, this is how we get a new instance. Okay, and it's called calling the constructor, which we'll learn about, or it's called constructing a party animal. Sometimes since we're creating an instance of party animal here, just one, it's sometimes called instantiating a party animal. So we construct one party animal, we save the reference in the variable an, and then we say we call a party 3 times. So given the code that we currently see in the party method, we say party, it'll say so far 1, party so far 2, party so far 3. Okay, that's what we're expecting. Okay. Now, what's kind of interesting here he says on the left side that when we call party, we're trying to tell the an object to run the party code within it. Here's where you start to see the metaphor that that these methods are messages. Okay, because when you call a method, aren't you sending it a message to exhibit behavior? Okay, I don't find that real helpful, but perhaps you do. Okay, so let's look at this. So here's our class again on the right side, and again we've combined the definition of the class with the client code that uses it for the benefit of just having a useful file to show you. Again, most of the classes that we are going to create are going to be reusable. We're going to save them in a module all by themselves, and we're going to import it. Okay, perhaps a module would be called party stuff, and we might say from party stuff import a party animal, and then we would break right into the code on the bottom here. Okay, but here this is teaching example, so we've combined the definition of the class with the use of the class, which you can do in the same file. So this is the same code that we had, okay? And you can see if we actually, from the command line, if we called Python party1.py, which is how you run a program at the command line, then we would get so far 1, so far 2, so far 3. The other thing that you see is this variable an, okay, is pointing to an instance of party animal, okay? Inside of that code, how do we refer to that instance as a whole? We refer to it with the kind of pronoun self. Okay? When we say self, we mean this instance, me, myself. I mean instance. I'm an. Okay? There's a reason we have both an and self over here. And a party animal has 2, in the wider sense, attributes. And in the wider sense, attributes are data attributes and methods. Okay, so the data attribute is the variable x. Okay, that's the instance variable x. And the method is party. Okay? Now, interestingly, we've been using this kind of stuff all along. We just haven't been defining them ourselves. Okay? So this kind of infrastructure and this kind of behavior, this is the kind of stuff that's been making our programs go. We just didn't realize we were speaking prose. Okay, now, if we play with the functions dir for directory and type for type, we can see some of the, well, we can see the attributes of these objects that we're creating. So this is a nerdy way to find the capabilities of an instance. Okay, so let's look. So we say y equals list. And this says create an empty list and assign it to the variable y. Okay, then we ask, what's the type of the variable y? Okay, and more appropriately, we're asking the question, what's the type of the value object that is associated with the variable y? Because variables don't have types in Python, only the value objects do. Okay, and it says, oh, its class is list. And then we say directory x. Okay, and I think we might have wanted to say a directory y. Okay, let's pretend that we said that. So we say it has all these things up front. We'll talk about what these are in a minute. But let's look down here at the bottom. What's at the bottom? Well, these are the real operations or methods that you could call on a list. And we know them. Append, clear, copy, count, extend, index, insert, pop, remove, reverse, sort. We know these. These are the methods that you can call on a list object. Okay? Well, these built-in types, okay, again, can you go somewhere and find the class definition for the list type? And well, it's a class list. Well, I looked that up this morning, and it says a lot of things. It may include class list, but it's a very long file. And it doesn't look exactly like the code that we're going to create for our classes. Perhaps it's hyper-technical because it's one of the built-in things. Okay, but you can think of it like a class, just like the kind that we create. Okay? Now, what are all these things up here? Okay, these are other capabilities that a list instance has. These are methods, and because they have these double underscores around them, Pythonistas call the double underscores, they say that these are dundered, double under, dundered. Okay, because of all the dundered method names up here, these are all important infrastructure parts of the class that are meant not to be called explicitly by the users of the class. Okay, well, what are some of the interesting ones? Stir. This is what creates the string representation of the list. Okay? So there are a bunch of things up here that are part of the infrastructure. That's why they have the dunders. Okay? We typically don't call them explicitly. Okay, when we call the function stir on a list, what does it do? Well, it usually calls the method dunder stir. Okay, but that all happens under the covers. We typically don't ever call these dundered methods explicitly in our program. Okay. Okay, so let's see what happens if we use the dir command to find out about the capabilities of our newly created class party animal. Okay, so on the left we have our party animal class and also a little bit of client code. We construct a party animal. What's another way we can say that? We create an instance of party animal. Okay, that makes sense. And then we say we want to print the type of that instance, and we want to print a directory of that instance. Okay, so the type is class main.party animal. So this is a party animal class that is created in the file. It was created as part of main. Okay. And then the directory says, what does it have? Well, it has a method called class. It's one of the dundered ones, so we're not going to call it explicitly. It has a couple of other things, but what does it also have? Well, it's got two attributes. One is a data attribute, X. Okay. The other is a method attribute, party. Okay. So all of the, in a wider sense, attributes appear on the directory list, including the data attributes like X and the method attributes like party. Okay. What does it ... say? Well, as a class, it's going to have a lot of other dundered methods that are automatically created for classes that we don't want to emphasize on this particular slide. All right, good. Oh, okay, so try a directory with a string. Now, you might want to crank up your Python command session and look at this. So if we say that X is equal to hello there, and we want the directory of X, you can see, wow, we get a bunch of these built-in dundered, we get a bunch of dundered methods that we're not supposed to call explicitly, plus a bunch of stuff we are expected to be able to call: capitalize, center, count, decode, ends with, where's upper to get to uppercase, where's lower is there, R just, L just. All the methods that we know we can call on a string. Pretty cool. So again, it's like that prose comment. We've been working with objects all along, and they behave in a way just like the objects that we create with custom classes. Now, I just want to point that there's something on the slide here that is not just like what we create with custom classes, and that is, how did we create this new instance of string? Well, we have, for certain of the built-in types, we have these ways of constructing instances with literal values. Okay, this isn't something that we can do, or it's certainly not easily done with our own custom types. So we've been doing this all along. If in fact we put a bunch of characters inside of apostrophes or double quotes, what happens is that implicitly we are constructing an instance of string. If we put the character 1 or 2 or 3 out here by itself, well then that becomes an integer literal, and the compiler will, the interpreter will construct an instance of int, and the same for float. Okay, so these special syntaxes that we have for literals in the code, that doesn't really, this isn't something that we're going to be able to do for our own custom types. Okay, it's the special kind of superpower that we give to the built-in types, and it's what makes the language easy to use. If we had to do it in the classic way that we construct new instances of our custom types, the language would just be too bulky. Okay, so let's talk about the object lifecycle. We kind of know about this object lifecycle in terms of the work that we've done with the built-in types, but maybe we haven't talked about it so explicitly. So let's do it. So the life cycle of an object is that objects are created, they're used, and they're discarded. Okay? We have special blocks of code, methods, that get called. Okay? At certain points in the life cycle. Okay? Why do we call them special blocks of code? Well, they're methods, but they're dundered. Okay? So we usually don't call them explicitly. In fact, we're not supposed to call the dundered methods explicitly. Okay? They're part of the kind of infrastructure. But when we create an object, there's a method that's got a special dundered name that is the constructor, and that's how the object comes into being. What the code that we usually put there is the code that could initialize the instance variables. Okay. Now, we can also have some code that can get control at the moment of destruction. And there's this thing called a destructor. Now, while constructors are used a lot, not all the times, we don't always have an explicit constructor. Destructors are used very infrequently. And you might want to say, well, why would somebody want to write some code when they destroy an object? Well, a typical use of this is when the objects are representing data that might be stored in a relational database. Okay, and so if you're using some kind of object relational mapper, okay, when you're working with rows in the database, they are objects of a certain type. Okay, can you simply delete them? Well, you could, but maybe you haven't updated the value in the database. Maybe you need to save that back. Okay, so the reason why we have these destructor hooks are for situations like that, where we've been keeping the values in the memory of our program, and before we destroy the object that's been holding the value in our program, we want to make sure we persist the value in the data store, like the relational database. Okay, we only do that occasionally, right? But constructors, on the other hand, a way to give initial values to the instance variables, these are very popular. Again, do we always have them? No. Sometimes we construct what I would call a blank object. We take the default initial values. Okay? But so destructors very rarely used. The constructors very popular but not universal, and that's the way they go. So let's talk about the constructors, because that's something. If we're going to create a custom object, that's something we have to learn how to code. Okay. So the primary purpose of the constructor is to set up some instance variables to have the proper initial values when the object is created. Okay. Now, this is something we haven't really talked about too much, but remember back when we started to talk about these classes, okay, and we started to talk about, we said they're really a blueprint. And if you go back to the slide that we were looking at when we claimed that, or the slide right before it, there was a picture of a cookie, a holiday cookie with a snowman on it. That was a snowman a cookie. And I think there was a cookie cutter there. Let's back up. Okay, I'm just going to see. Where am I? I'm on slide number 27, and I'll be back here. I just want to go back to the cookie cutter. It's oddly enough, it's an important metaphor. There we are. Okay, so there's the snowman cookie and the cookie cutter. Okay, so what a lot of people like to say is that when we create new objects, it's like it's like we are cutting cookies out of plain dough. Okay, well, all right. So if we think of the class as a cookie cutter, that's a good metaphor for that. Okay. Now, I just want to ask you this: when you cut out a piece of a cookie dough with a cookie cutter, does it already have the icing and these little sprinkle objects on it? No, it doesn't. Okay. So, think about that. Wouldn't that be some activity you would do next? So maybe you would cut out a snowman cookie and then you would decorate it. Okay, you would put the things on it that you wanted on the cookie, and then you would bake it, right? Okay, so let's think about where the constructor actually comes in. Is the constructor the cookie cutter, or is the constructor the thing that puts on the icing and the sprinkles? I'm going to tell you that I believe the constructor is the thing, regardless of its name. It's the thing that puts on the icing and the sprinkles. Let's go look. So we're up on 27. Here we are. Okay? And let's go back to full screen because I like that. Mm-hmm. Okay, there we go. Okay, so the purpose of the constructor is to set up some instance variables to have the proper initial values when the object is created. Well, isn't that like putting on the icing in the sprinkles? Okay. So some people like to teach that the constructor is the cookie cutter. And I'm going to say that by the time the constructor runs, the constructor is really a special method, we're going to say. By the time it runs, we already have a cookie. We already have a blank object, okay? And we're going to fill in appropriate values, okay? Isn't that more like the decorating phase of cookie making? And then, of course, you bake it. Well, the metaphor only holds true for so long. But if you're really thinking of the cookie making metaphor, the constructor is more like the one that puts on the flavorings and the decorations on top of the cutout cookie dough than it is like the cutter itself. Okay, so here we see a constructor. right here. So it says def dunder init. So the name of the constructor is init, initialize. That sounds like putting on the icing and the little sprinkles too. Okay. Now, one of the interesting things here is you can do whatever you want to in a constructor. He just decided to so you would see what the life cycle is. The constructor, okay, is simply uh, printing a message. This is pretty typically things that we do when we're trying to show the life cycle of something. So, is the primary use of a constructor to print out a life cycle message? No. Okay. But that's a good job to give it if you want to see when it runs. Okay. We also have a destructor. Again, we don't create these a lot, but it's a dunder del. Okay, this is like the delete function. If you call the delete function on an object by saying del and then in parens, I'm sorry, it's not the delete function. It's the delete operator. So you just say del and then the name, and it calls it calls the destructor. And again, this is just saying I am destructed self x. Now, I just would point out if that was true, then you wouldn't be able to print self.x. Am I right? I am right. And then down here, let's see, we construct a party animal. We call party twice. Okay. We give it the value 42. Okay, then we print an contains, and then we get the value 42. Okay, so with that as our life cycle scenario, what do we get? We get well, we start the program at the command line. That's party 4. Apparently, that's what we're calling it. We can't see it because we can't see the shell that's around the. We can't see the name of the file that's over here on the left side. And then it prints, I am constructed, so far 1, so far 2. I am destructed 2, an contains 42. Okay, now I just want to point out that this 42 is not the first object. Okay, what has happened? Well, this is how the object gets destructed. Okay, how could you destruct an object? Well, there are two ways. One is to use the del operator, but the other way is to just get rid of the reference to it. So when we get rid of the reference to the variable an, it's pointing to a party animal object. When we say n equals equal 42, or an gets assigned 42, what are we doing? Well, we're saying we want it to be associated with this new integer value, 42. Okay? So what happens to the party animal object? It gets destructed. Okay? And then we print an contains an, and of course what you're seeing is the behavior of an int value object. Okay, so the destructor is seldom used. We seldom create an explicit destructor. And why is that? Well, because again, typically we would want to do things like make sure we persisted the value of that object in the relational database backend, or something like that. And that's a very small fraction of the amount of times that we're declaring uh, custom objects with custom classes that you and I create. Okay, so let's talk about the constructor again, because this is the thing we're going to have to learn how to create. And again, what's up here? The cookies are up here again. All right. So again, my challenge for you is when you think about this, how are you going to think about the constructor? Is it this cutter, or is the constructor that puts the pretty decoration on the cookie? I think it's the latter. In object-oriented programming, a constructor in a class is a special block of statements called when an object is created. So at creation time. So we can have many instances of our objects. Now we're used to this. Okay, we've been writing programs all along that have a lot of instances of integer. Some of them have a lot of instances of float. Some of them have a lot of instances of string, and we think nothing of it. Okay, some of our programs have more than one list or more than one dictionary, right? And we're completely comfortable with that. Well, we can do the same thing with our custom types that we create with these classes that we define and write ourselves. So we can create lots of objects of a given type. The class is the template for those objects. We can store each distinct object in its own variable, okay? Or we could store a whole collection of them in a list. Or they could be some of the things we put into a dictionary, okay? We call this having multiple instances of the same class. Each instance has its own copy of the instance variables. That's why we call them instance variables. There's a set for every instance. So let's explore that a bit. Okay. Well, actually, we're exploring the practicalities of constructors. Okay. So again, what's the primary use of constructors? Well, it's not to print a lifecycle message, like down here. Print self.name constructed. Well, that's a nice kind of a learning tool, but that's not what we typically do. Okay, what do we typically do? Well, we typically initialize the value of the instance variables. How are we going to do that? Well, we pass in a parameter, okay, that gives the initial value or values. Okay, so for our party animal class, which is a very simple class, we only have one instance variable. So typically we would only pass in one value. Well, what's this self? What's going on with self? Well, self is an interesting thing. Every function that a class has, every method that a class has, they really behave like functions that are owned by objects. Okay, so when you're in that function, how do you refer to the object itself? Like, how would you refer to its own instance variables? Well, we need a formal parameter that allows us to do that. So implicitly, every time we call a method, when you get into the method, there is a parameter that wasn't on the parameter list in the calling code. Okay, it's just automatically inserted at the beginning of the list. and it's a reference to the object itself. Okay. Now, what's the object itself? Well, let's look down here to the using code. Okay. If we create a party animal called Sally, okay, and we save a reference into the variable s, okay, and then we say s.party, and this is a typical object-oriented syntax. What is the self? Well, it's s. Okay, so on the calling code, we can see what the self is. It's the name before the dot. Okay, how do we know? How can we refer to that thing? How can we refer to the object that we are inside the called code? Well, that's why we get this implicit first formal parameter called self. So how do we refer to ourself in the called code? Well, here with the formal parameter, self. Okay, and then how do we refer to the object itself in the called code? Well, it's just the variable name. Okay, so in the two contexts, they're referred to in two different ways, but that's the reason why this self first parameter is always created implicitly when we call a method. Does that happen with functions? No, because functions aren't associated with objects. This is a key distinction between functions and methods. In fact, it's one of the few distinctions between the two. Okay, so what happens is that when we construct party animal and pass in Sally, what gets called? Well, the dundred init gets called. And what's on the parameter list? Well, self. It's a method. It always gets a reference to the object itself, plus anything we passed in. Well, we passed in Sally. Okay, so when we assign z, which again is not a well-chosen parameter name, okay, it's just we're trying to fit everything on the slide. Okay, when we say self name z, then we say print self.name constructed. What do we get? Well, we get on the first one we get Sally constructed. On the second we get Jim constructed. Okay, and here we called on Sally we called a party once, and on Jim we called a party twice. Okay, and here's a party. Okay, the first parameter to each of the methods is always this implicit parameter self. Okay, do you see it on the list when you call party? Well, not in this part, but again, where is it hiding in this expression? Well, it's in J, just like it was in S. Okay, so because the notation in the call code is different than the notation, the notation in the calling code is different than the notation in the called code. What's represented by the variable name in the calling code is represented by this first parameter on the method parameter list, which is always called self. Okay, and in my class where we use PyCharm, when we create a method, when we declare a method, it always tries its best. It's best to put in that first implicit parameter self automatically to remind us to do it. Okay, so in party, how do we increment the instance variable x? Well, we refer to it as self.x. How do we print it if we want to? Well, we refer to it as self.x. Okay, that's how we do it. So let's look at uh, let's take a look at these object instances um, and what values that they have. Okay, so we have two instances of the party animal class, and we're used to multiple instances of things. We've written programs, as I've said before, with more than one integer instance, more than one float instance, more than one list instance, more than one dictionary instance. We just haven't been making a big fuss about it. Just like the the character in the Moliere play, he hadn't really been thinking he'd been speaking in prose, but he decided that he probably had. Okay, well, same deal here. So we've got two instances of the party animal class, two party animal objects, as we say. One is being referred to by the variable s, okay? The other is being referred to by the variable j, okay? Each of them has um, two instance variables now. Okay, now, I'm not sure I really pointed that out so explicitly on the last slide. We've added the instance variable name, okay, and we gave it the empty string as its default value, and so in it we're not passing in an initial value for x, which I guess is the number of times we've partied. So a better name for x would be party count, right? But we're passing in a value for the name. And again, x and z are horrible names. Okay, so each of these has a value for x and for name. Right now, on the right side, we're not showing what their values are, and I'm not sure why the slide is like that. If at the very beginning of the constructor, x would equal 0 and name would be blank, when we finish the constructor code, x would be 0 and name would be whatever the name is. I think they were Sally and Jim. Yeah, they're Sally and Jim. So why we're not showing the values out here is a little bit hazy to me. Okay, perhaps when we generated the PDF from the slides, we lost something. Sometimes when you do that, you don't get the parts of the slide that build. So perhaps I was supposed to hit a key and the values were supposed to slide in from the right. Something like that. But think of them as having the values that they have. Okay, so those are the basics of custom classes. Okay, we can define them ourselves. And to review, classes are templates or blueprints for objects. So if we want to create our own individual kind of object, we're going to create a custom class. Okay, they have data and behaviors. Okay, in some kind of a wide sense, both the data and behaviors are both called attributes. Okay, the data are more properly called data attributes or instance variables, and the behavior attributes are more properly called methods. Okay, and we can have as many instances as we need, and perhaps as practically we can fit into the memory of our computer, because they all take up a little memory. Okay, now we've got one further topic about classes and objects that is a little bit of a mind blower. Okay, and it's where the real power starts to come in on uh, object orientation. Okay, and so we're just gonna cover it here in this beginner course for Python. Uh, Primarily in a beginner course for Python, we want you to know how to use other people's objects. Okay, and we've been doing that. Okay. Then we want to make sure before we get done that we teach you how to do a simple job of creating your own objects. Well, we just did that. And now the last thing we usually do is we talk about this whole inheritance thing and at least get you kind of dreaming about the kind of power that comes from that. Okay? So there's a reference here. Let's see where this goes. Oh, well, here's a whole article on inheritance and polymorphism. Okay, and I'll leave that for you to read on your own. Okay, I wonder where that went. So let's go. So, what's inheritance all about? When we make a new class, we can reuse an existing class and inherit all the capabilities of an existing class, and then add our own little bit to make our new class. So, why do we do that? Well, generally speaking, one of the principles that we've tried to follow throughout our whole course is avoiding duplicate code. And why do we want to avoid duplicate code? Well, one reason is that we don't have to want to write it twice, or 3 times, or 4 times, or 100 times, right? 2, we don't want to have to test it more than 1 time. Really testing code well often takes at least as long as the coding does. And then 3, the most important thing is that once you create code and you test it and you have confidence in it, you have to maintain it for life. Okay? And some of these programs have a pretty long life. I mean, I've been programming for over 40 years, and I bet somewhere there are programs that I wrote for hire, either as an employee or as a consultant, that are still running 20, 30 years later. Okay? Now, somebody's had to maintain them that whole time. Okay? So, one of the reasons why we use inheritance is like all the other things that we've learned how to do to eliminate duplicate code. Better to build on some part that we've already designed and coded and tested and maintained over time than to create a new one that has to have that overhead associated with it as well. Okay, so that's the motivation that we have. Okay, we want to build on top of the prior accomplishments of ourselves and others. It's another form of store and reuse. Write once, reuse many times. The new class, the child, has all the capabilities of the old class, the parent, and then some. Okay? So here's the terminology. So the general object-oriented term is inheritance. And we talk about subclasses and super classes. And I just want to begin by saying the super aspect of superclasses is a misleading word. Okay? And I'll get there in a minute. So subclasses are more specialized versions of a class which inherit the attributes, the data attributes, and the behaviors, so the fields and the methods from their parent classes, and can introduce their own further attributes and methods. Okay? So, think about this. If a subclass inherits all the characteristics of the superclass and then adds its own, is it less powerful or more powerful than the superclass? Well, it's got more functionality than the superclass does. So one of the reasons that I think that superclass and subclass were not that well chosen was they do they do whereas on one hand super and sub um, uh, they explain a kind of a hierarchical relationship where the sub inherits from the super. And when we draw these on design charts, either class diagrams or other kinds of class hierarchy charts, we'll see that that the superclass is usually up top. It's a rectangle up top, and then the subs are down underneath, and they have a line between them and arrows and all that kind of stuff. So you kind of see subclasses being subordinate, but they've got more powers than the superclasses. Okay, so in a way, the sub is more powerful than the super, and this gets us back to uh, the terminology that we used on the previous slide, child and parent. I think you ought to think of supers and subs just as well as the super is the parent class and the sub is the child class. And if you really think of it, what do we all wish for our children? We all wish that they had our capabilities, none of our faults, and that they had other capabilities on top of that. I mean, that's kind of the wish that, as a parent, I can tell you that's the kind of wish that parents have for their children. Okay, so instead of superordinate and subordinate, thinking of them as parents and children is I think the right kind of metaphor. Okay, they're called supers and subs. Sometimes they're called parent and child. Again, we in the field tend to break from one set of language into another pretty seamlessly, which for beginners can be pretty confusing. Okay, so subclasses are more specialized versions of a class, the superclass or the parent, which inherit the attributes and the behaviors from the parent so they can know all the things that the parent, an instance of the subclass can know everything that an instance of the superclass can know. It can do everything that the instance of the superclass can know, plus it can know and do other things. So it's really more powerful, even though it has this word sub hanging off of it. So let's think about how this could be. Well, one of the things that you can do is that you can take a class that you already have, and you can inherit from it. Okay, so we already know the party animal class. The last time we wrote the party animal class, it looked like it did on the top left of the slide. Okay, now here's what we want to do. We want to create a football fan class. And again, this is probably the Big Ten influence. Okay, so a football fan. What's in the parens? The name of the superclass, the name of the class that we inherit from. Okay, now because of the semantics of inheritance and supers and subs, okay, we one test of whether a sub is a proper sub is whether it passes what we call the is a test. Okay, a football fan is a party animal. Okay, now you as a football fan may agree or not agree with that assertion. Okay, but in the world of this course, a football fan is a party animal, which says it knows all the things that a party animal knows. It does all the things that a party animal does, plus it can know other things and do other things. Okay, what can it know in addition? Well, it can know points. It can know the score. So it has an additional instance variable. Okay, and it has an additional method. Okay, so at the beginning, when we construct the class, it has, in addition to having the instance variable fields x and name, it also has points that has initial value of 0. Okay, and then every time we call touchdown, it adds 7 points to the points. Okay, now this is a pretty simplified version of a football fan. Apparently, they don't know that you score 6 points. And apparently, we've left out the possibility that you can score field goals. So it's probably all the partying that they've done that has had that effect. Okay. And so over here on the right, here's the client code. So we say we have the variable s. It's going to hold a party animal called Sally. You can call party on her. And then we have J is a football fan named Jim. You can call party on Jim and touchdown on Jim. Okay. If you tried to call a touchdown on Sally, it would blow up. It would say that she doesn't have that method. Okay. So what's interesting is that each instance knows what it's an instance of, and it has the appropriate fields and methods that apply to that kind to that class of object. So the object being pointed to by S knows it's a party animal object. Okay, so it knows that it's got the variable X. It knows it has the variable name. It knows that it has the method party. The object pointed to by J, it knows it's a football fan. Okay, so it knows it has all the capabilities of a party animal, plus it knows that it has the data points and the behavior touchdown. Okay, which, of course, in terms of super and sub, are not the typical ways we think of those kind of terms. What's a superhero? Well, it's a regular hero plus extra capabilities. Well, the word super is probably more appropriate in terms of our typical meaning of super in the workaday world than here. Okay, so subclasses create instances that are more powerful than superclasses do, unlike comics. Okay. So, we've got a couple of more things. So now we say, here's Sally. She has a value for X and she has a name. And here's Jim. He has a value for X. He has a name. He has a value for points. Okay? So, what are some of the definitions that we covered in this overall unit on object orientation and classes? So, it's best to think of a class as a template or a blueprint. So the thing to think of as the cookie cutter is the class. Okay, when you create an instance of a class, you cut out a cookie. What's it cut out of? Not cookie dough, probably just electrons and memory space. Okay, what's an attribute? Well, in the wider sense, that is not what Severance uses in the slides. An attribute of a Python class is either a variable or a method. In the narrower sense that he uses it here, a data attribute is an instance variable within the class. A method is a function within the class. It just happens to know that it's part of that instance. What's an object? An object is a particular instance of a class. What's a constructor? A code that runs when an object is created. Note that we don't claim that it creates the object. Okay? The Python infrastructure uses the template or the blueprint of the class to create the object. What does the constructor do? It initializes the object, which means it puts on the icing and the sprinkles. Okay? And what is inheritance? It's the ability to extend a class to make a new class. Okay? Which, oddly enough, in spite of the terms super and sub, instances of subclasses have typically hold more data and more behavior than instances of the superclass, notwithstanding the names sub and super. So, a summary here. Object-oriented programming is a very structured approach to code reuse. We can group data and functionality together to create many independent instances of a class. And we've been doing that all along. We just didn't know we were speaking prose. And here's some acknowledgments. And if we go another slide, there's actually a link to the cookie slide, right? So here's the cookie slide. Let's bring up that. I like that. This is, I think, a good cookie slide. What I like is it gives you the opportunity to talk about the decoration. So I like that a lot. And what's the other one? Well, here's a shot from the TV show Lassie. And here's Lassie, and here's Timmy. And apparently, at this point in the episode, Timmy hasn't gotten into trouble yet, so he's not down a well. So Timmy could get himself in some pretty bad fixes, the worst of which was when he was down the well. All right, that's it for this lecture. I'll see you again in my tutorials for the exercises. Until then, I'll say bye. Bye-bye.